Hello everyone. I hope you are safe at home. We know that there's a challenge in front of us. The pandemic that has spread across the country. We have to face it and come victorious. And all the civil service aspirants, we know that we should always be ready for the challenge. And we are being tested so far. We are being tested. We will come victorious for sure. So keep your preparations ready. Keep yourself ready for exam. So we are making our first attempt to help you in your preparations, and the topic that we have chosen is the cyclone. We know that Amphan has created havocs in eastern part of the country, and recently it has become super cyclone. It has been declared as a super cyclone. So in today's discussion, we'll be discussing a little bit about how cyclones originate, what are the conditions for the cyclonic formations, and what is super cyclone and why cyclones became so strong this year, and future predictions of cyclones as well. So let us see what is a tropical cyclone. Tropical cyclone. See, all of us have seen videos of cyclone. All of us have known what is cyclone. That swelling wind that passes through with a very high speed of winds. Something like this. Having very high speed of winds, which ranges, of course, around 150, 200 kilometers per hour. And it can range up to, it can even go up to 400 kilometers per hour. So, what is basically a cyclone? The definition is very simple. Definition says any intense low pressure condition. Intense low pressure condition. And that intense low pressure condition is accompanied with very fast flowing winds and accompanied with fast flowing winds, fast flowing winds and heavy precipitation. And heavy precipitation. Now all the videos of cyclones and tropical cyclones across the world, be it cyclones, be it hurricanes, be it typhoons, Typhoon or Willy, all of these have very high speed of winds and cause so much of rainfall that it even causes flash floods. So what makes cyclones so strong and what is the reason for cyclone? That is the basic discussion. Before I go to the what is tropical cyclone, I will be discussing the conditions in which cyclones originate. Conditions in which cyclones originate. Now, the first condition for cyclonic formation, and I always have said that it is more than a condition, it's an indication that the sea surface temperature is 25 degrees Celsius to 27 degrees Celsius. Now what happens because of this high temperature of the sea? As the temperature is high, the rate of evaporation increases. Rate of evaporation increases. So it's very high when the sea surface temperature increases beyond 25 degrees Celsius. So it is not that at every 25 degrees Celsius the cyclones will originate. It's an initial point. Then we have another condition which leads to cyclonic formation, and that is warm ocean currents. Warm ocean currents. Now see, what are ocean currents, and the discussion on ocean currents will be also discussed will be held in the next discussion. We will be discussing in detail what are ocean currents and what are the impacts of the global impacts of ocean currents. As of now, just taking a reference of ocean currents, just try to remember this, that suppose this is a continent and this is an ocean in between two continents. So at equator, what we experience, what we see is that ocean currents, that is surface water of ocean, has westward movement because of reasons like prevailing winds. We know that there are trade winds which push water towards west and so on. So ocean currents move from east to west. On the western side, they move towards poles. So from the western side of oceans, you can see that ocean currents moving towards poles because of temperature difference. And then we'll see in the discussion on ocean currents what happens beyond this. But what is the important point here to note is that warm ocean waters from equator reach to the tropical and subtropical part. See, these arrows show that warm oceanic currents move towards tropical and subtropical part. So if temperature increases because of warm ocean currents, it will further increase the rate of evaporation. It will further increase the rate of evaporation. Now, it should be clear here, one thing should be clear. In both the points, be it the sea surface temperature, or warm ocean currents, we are emphasizing that it leads to the higher rate of evaporation. Now, what happens because of this higher rate of evaporation? See, if you keep your hands on the boiling water, you feel that heat of vapors. That's because if there is an evaporation, like suppose there's any surface, any water body, and there is evaporation, water vapors possess latent heat of evaporation. Latent heat of evaporation. So they are warm, they possess energy, they are in gaseous form, lighter, so therefore begin to rise up. So if a rate of evaporation is higher, it will lead to low pressure conditions. Atmospheric pressure decreases. So that's why these two, the rate of evaporation is very, very important. It is very, very high before the cyclonic formation. Next condition, if we emphasize upon the next condition, then you can see third condition, most of the cyclones originate in regions closer to ITCZ. Proximity to ITCZ. Now, what is this intertropical convergence zone? In pressure belts, in discussion on monsoon, it's very, very important to understand. As of now, I'll just briefly discuss this, that ITCZ is formed in a region where the sun rays are vertical. And in a brief discussion, we can on the seasonal changes of sun, we can understand that sun rays are vertical at equator during equinoxes, they are vertical at Tropic of Cancer during summers, and they are vertical at Tropic of Capricorn during winters, the summer solstice and winter solstice and equinox condition. So, what happens because of the direct sun rays? Again, the temperature increases, so air flow is upward. Air constantly rises up because of direct heat. So, it is also convergence zone of trade winds. Trade winds from the subtropical region, subtropical high pressure region, come towards the equatorial low pressure region, become very hot and then rise up. This further induces the chances of formation of intense low pressure zone. So cyclones originate in regions closer to ITCZ. This is our third condition that we need to focus upon, proximity to ITCZ. Now, let's see another point, another condition, and that is stable air. Those who are not clear with the stable air, I'll just write very simple explanation for the stable air, that is clear sky. Clear skies. Now, what is clear? Why the stable air, clear sky? Why does it help in the cyclonic formation? It's very simple to understand. Clear sky means less clouds. Less clouds means stronger insolation. Insolation. So clear skies, stronger insolation, and higher temperature, higher rate of evaporation. So cyclonic formations can take place. There is one important point that we must all understand. See, what has happened this year is because of the COVID-19, the aerosols in air, atmosphere, is relatively lesser. It's much lesser than previous year or prior to that. Now, what happens because of aerosols? They attract moisture and lead to the cloud formation. They accelerate the process of cloud formation. Now, this year, because aerosol concentration is less, the cloud formation is also less. And because of lesser cloud formation, we have more clear sky and therefore stronger insolation, which has induced this recent cyclone Amphan. So if we see the conditions, I'll repeat these conditions once again. So sea surface temperature, I hope it is clear. Warm ocean currents, which will both of them will lead to the higher rate of evaporation, induced low pressure, proximity to ITCZ, air masses converge, rise up, lead to the low pressure condition. Stable air, insolation, again leads to the heating of atmosphere and movement of air masses, vertical movement of air masses. Now, if you see that there is a movement of air, I'll put a huge bracket under this. Another condition which is very implicit, of course, we all know this, that if air is moving, if there is movement, there must be a pseudo force, a kind of invisible force that is applied here, and that is Coriolis force. Coriolis force. Other than equator, we know that it's present everywhere. The Coriolis force doesn't cause deflection at equator. It's more prominent towards poles, but any object moving along the surface of Earth, flying or flowing along the surface of Earth, experiences gets influenced by this Coriolis force, which deflects it toward right and left. In my next video, I will be elaborating on what is Coriolis force and how Coriolis force causes deflection. So as if now we just remember this Coriolis force. If some of you are not clear with what is Coriolis force and how does it cause deflection, remember that just the statement I am referring to, the statement that was given by Ferrel, and we call it as Ferrel's law, that is, any object moving in northern hemisphere gets deflected towards right of its direction. Any object moving in southern hemisphere gets deflected towards left of its direction. So if an object is moving from equator to poles, deflection is towards right, that is towards east. Object from equator to poles in southern hemisphere, deflection is towards left, again towards east. Opposite, if an object is moving from poles to equator, the deflection is towards west, towards right of the moving object. Again, in the southern hemisphere, if the movement is from poles to equator, deflection is towards left of the moving object, that is towards west of it. So as I said, I'll be elaborating this Coriolis force probably in the next video. So this is a huge force that is applicable on any moving object. So these are conditions that lead to the tropical cyclones. Now in the next discussion, next video, we'll be discussing origin of cyclone. Why and how does a cyclone originate? And after that, the recent aspect of cyclone, that is the distribution of cyclone, and what are the recommendations that we should do for the disaster management.